Okay, so today we're going to talk about graphing from a vertex form. A vertex form is just another way of looking at quadratics. When we look at a normal quadratic function, we look at it in this case here, where we have y equals a times x minus h squared plus k. This is the vertex form. It's showing showing all your information. It gives you your a, it gives you your h, and it gives you your k. And we can use those to determine what our different parts, like our vertex and our axis of symmetry and things like that. We can figure that from this form. And we have talked about the vertex form before. Now what we're doing is we're also introducing in with the absolute value symbol. So before we've used parentheses, now we're using these absolute values. And the difference between the two is the absolute value functions create straight lines. They connect the points using straight lines. They still have the arrows so that your domain is still going to be all real numbers, and your range will again start at the vertex and go up. You do have a vertex and you do have some points, but the important part is it's the straight lines connecting those points. On a quadratic function, then we have the parentheses and it's being squared, and in this case they have curved lines. Remember, your vertex is HK and on both, doesn't matter which one, and your axis of symmetry is whatever your x value is or your h in your equation. Okay, so we have this absolute value function here, and we have the absolute value of x minus 4 plus 5, and because I know it's a times x minus h plus k, my h is 4 and my k is 5, so that gave me my vertex. And then I was able to just plug in numbers on both sides, so I started with the 3, and so I had 3 minus 4 inside absolute values plus 5. Well, this is -1, and the absolute value of -1 is +1, so I get 1 plus 5, and that gave me 6. And then I plugged in 2, so I have 2 minus 4 plus 5. So 2 minus 4 is -2. Absolute value of -2 is +2, and so 2 plus 5 is 7, and so that gave me my 7. And then I did the same for 5 and for 6, and this is what I came up with. My axis of symmetry is my x value, which is 4, so x equals 4, and my vertex is at 4, 5. When graphing this, I can see that is well above the origin for the vertex, and it is also, everything is positive. So what I need is a, oops, I don't need that. I want this one. So I'm going to create a graph where basically all I need is the first quartile. So when I take a look at this, I'm going to count them by ones. So 1, 2, up to 7. 1, 2, 3, 6, 7. It's off by just a little bit. 3 and 6. 4 and 5. 5 and 6. And 6 and 7. And in cases like this, when I graph them, I know that they're going to be straight lines. And then I have my arrows on them. Because it has an absolute value, these are straight lines. So if I take a look at this one, and I want to know what my vertex is, I have a -2 times x plus 4 and then I don't have anything, but I know I can say plus 0. So because it is minus h to get h, that means that my h has to be -4 for this to work, and my k is going to be 0. So there is my ordered pair. That is my vertex, -4 and 0. I can test to see if this is actually true by taking -2 times -4 plus 4 plus 0. This is 0. The absolute value of 0 times -2 is 0. 0 plus 0 is 0. So that is my vertex. My axis of symmetry is going to be -4. So now I can go -3, -2, -5, and -6, and I can solve for all the y values on those. So what I did is I just plugged in for x my -2, and I got -4. I plugged in -3 for my x, and I got -2. And I plugged in -5 for x, and I got -2. And then this last one, because it was repeating, I just went ahead and put -4. Now we need to go ahead and create our graph. Because all of our x values are negatives and all of our y's, except for this one here, are all negatives, I'm going to draw my grid like this. And I've got -2, -4, so 1, 2, 1, 2, 3, 4. -3, -2. -4, 0. 5, -2. And 6, -4. And then when I graph my lines, I'm making sure that they are straight. And that I have an arrow on both ends. And there's my graph. Okay, if you have any questions, please make sure you see your teacher. Thank you.